A pleasant morning to everyone. I am Katrina Villafuerte and together with my co-researchers, Eishabel, Samantha Cabagnot, and Francheska Limshong, we will be presenting our research entitled Zeolite as an Additive in Human Hair Compost, Evaluation on Plant Growth. We will be presenting our paper's introduction, materials and methods, results and discussion, and conclusion. Daily increases in fertilizer requires led to pollution, waste, climate change, contaminated water, and nutrient flow. To avoid these possible negative effects, chemical fertilizers must be replaced. Composting has downsides, including nitrogen loss, high HM mobility, GHG emissions, low compost quality, and antibiotic-resistant gene enrichment. Despite the fact that it may successfully recycle organic solid wastes, it is being researched how to enhance compost quality and lessen the aforementioned negative effects by adding additions like zeolite. We are to make a model to help farmers make compost for plants that is ecologically beneficial. The magnet-like qualities of zeolite make it a popular component in hair treatments like dry shampoo. It has been demonstrated to be a powerful natural antibacterial and efficient in removing dangerous byproducts from materials for purification, including radioactive wastes, cationic heavy metal species, and ammonia. Our research evaluated zeolite as an additive in human hair composts in support of plant growth. Researchers assessed the effects of human hair in zeolite on root growth capacity and evaluated the influences of human hair and zeolite on plant growth rate. We also investigated the exact ratio of human hair and zeolite needed as organic compost in plant growth, done by assessing the effects of human hair and zeolite on soil fertility, plant quality based on pH level, electrical conductivity, moisture level, temperature, height, and the number of leaves. Analyzed the impact of combining zeolite and human hair and composted as an alternative organic fertilizer, developing an effective and economically friendly model for farmers. We also then evaluated the effects of zeolite as an additive in human hair compost and plant growth. Following this, our methodology includes the following procedures: review of related works, composting development, planting, monitoring, data collection, SEM and DX testing, data analysis, and report writing. Shown on the slide are the pictures of various weight ratio of zeolite and human hair. The research then adopted a qualitative and quantitative approach. The qualitative method involves assessing the effects of human hair and zeolite on soil fertility and plant quality and design of plant growth through a quantitative analysis of the data gathered in an experimental design. The soil had a thorough examination and the soil sampling followed the proper standard procedures in the laboratory. The relationship between crop yield, the soil test level, and the nutrients present within the soil was assessed and analyzed to see if it adequately ranges for the needed crop production. On the other hand, evaluated plant root growth and growth rate determined its effect on plant quality.
A soil fertility assessment was conducted wherein the growth medium pH, electrical conductivity, and temperature of the initial soil samples were collected after a week, and the final soil samples were collected in the 5th week through the use of 1-2 testing method to collect leachate. Followed by a plant quality assessment where the height and the distance from the plant container's edge to the summit of the main plant stem of the initial plant sample was measured, and the number of new tips and visible leaves were recorded. Thereafter, scanning electron microscopy with energy dispersive X-ray analysis was conducted on the human hair and zeolite samples with the guidance of Mr. Anthony Santos. Data collected from the 1-2 soil testing method was analyzed through the use of optimal values for lactica sativa to determine its susceptibility and to graph the plant quality data to visualize each of the treatment's plant growth. Lastly, a report writing of an overview of the monthly process of the study was done. The study hypothesis under examination was tested by the analysis of the measures gathered from the evaluations. Results will be compared and analyzed using tabular data. The pH of the growth medium and the electrical conductivity of the soil was measured using the 1-2 soil testing method at the beginning and end of plant growth. The soil alone must be used for the moisture meter in this manner, and the leachate collected must be further measured by the bench type RS232 USB. This quick and affordable tool determines the EC of the solution within the substrate pores. With this approach, the leachate collection must also be monitored using an EC meter and a pH meter. Tools for measuring length, such as a metric ruler, are necessary for performing common plant morphological tests. Present ethical issues within the study were each assessed and navigated accordingly. Withal, it is determined that the ethical issues present within the study are safety consumption, sourcing human hair from willing and informed participants, the safety during the experimental process, and the safety of the environment. Firstly, the safety of the consumption of the variables to be used, such as the types of human hair and zeolite, will undergo testing to search for possible allergens to assure consumers' safety. Secondly, sourcing human hair will be assumed to be consensual and will inform the participants of what it may entail. Thirdly, to ensure safety, the instruments and variables handled were researched on their proper handling and protocols. Lastly, extensive research on the properties of human hair took place. For the quantitative analysis, our optimum values for the pH and the electrical conductivity are shown in the screen. The pH is ranged from 5.5 to 6.5, and the electrical conductivity is ranged from 0.4 to 0.9 ms per cm.
The data from each plant sample soil fertility assessment from weeks 1 to 5 are represented in a table on the computer screen. In contrast to the improved outcomes of control and pure zeolite, the final pH results of 10% zeolite, 25% zeolite, 40% zeolite, and pure hair drastically fell relative to the beginning pH while maintaining the desired range of 5.5 to 6.5. Final electrical conductivity results exceeded the desired range interval of 0.4 to 0.9 ms per cm, with significantly high electrical conductivity levels in treatments 10% zeolite, 25% zeolite, 40% zeolite, and pure hair, and low electrical conductivity levels in treatments control and pure zeolite. However, 40% zeolite remained the only treatment with a value within this desired range of at least 0.4 over weeks 1 to 4, and this was true for all 4 weeks. Data results of the plant quality assessment from each plant sample from weeks 1 to 5 shows a direct relationship between plant height and number of leaves. Treatments control 10% zeolite, 25% zeolite, and 40% zeolite show a steady increase in plant height over the weeks compared to pure hair and zeolite. In analyzing the growth pattern of plants across different treatments from weeks 1 to 5, a trend becomes apparent in the study. Treatment Z, which represents pure zeolite, exhibited the lowest plant height growth rate with a significant decrease during week 3. Treatment H, representing pure hair, exhibited the highest plant height growth rate with a significant increase during week 4 and a subsequent decrease during the 5th week. Treatment 40, which represents 40% zeolite, followed by the second highest plant height growth rate, showed a steady increase throughout the assessment period. Moving on to the number of leaves, the control treatment showed a steady increase throughout the weeks. Treatment zeolite exhibited the most significant increase compared to the initial results, going from 6 leaves to 10. However, it's worth noting that during the 5th week, a decrease in the number of leaves was observed. After treatment zeolite, treatment control, and pure hair displayed a sequential pattern in the number of leaves that they yielded. Pictures presented on the screen are the final results of the plants of each treatment after 5 weeks. The study reveals that the addition of zeolite to the compost leads to a significant improvement in soil and plant quality. Using a 40% dry weight zeolite composition proved to be effective as compared to the use of pure substrate, as this ratio consistently maintained optimal values for soil pH and electrical conductivity while promoting steady plant growth. Scanning electron microscopy (SEM) with energy dispersive X-ray analysis (EDX) revealed the natural zeolite consists of 53% oxygen, 24% carbon, 13% silicon, 1% sodium, and 1% calcium. Human hair, on the other hand, contains 56% carbon, 23% nitrogen, 18% oxygen, 2% niobium, and 1% sulfur. Carbon-rich zeolite and nitrogen-rich human hair provide essential nutrients to plants. The presence of higher carbon content in zeolite slows down decomposition, benefiting plant photosynthesis. Additionally, the increased oxygen content in zeolite in human hair enhances moisture retention, contributing to overall plant health and root growth. It revealed that the human hair exhibits higher carbon content, lower nitrogen content, and higher oxygen content, while natural zeolite showed lower carbon content, negligible nitrogen, and higher oxygen content. The lower nitrogen content in human hair may affect plant growth, as nitrogen plays a vital role in protein synthesis. Traces of niobium and zirconium were found in the human hair samples, likely from the sample holders. The lower silicon content in zeolite may lead to nutritional deficiencies, and the reduced plant yield due to limited nutrient absorption. Based on our comprehensive analysis, the presence of nitrogen and carbon has emerged as critical factors in energy production and tissue development within plants. Our findings suggest that the carbon content found in zeolite enhances photosynthesis, while increased oxygen levels contribute to improved moisture retention and plant hydration. The varying chemical composition of human hair is characterized by higher carbon and oxygen content, but lower nitrogen content may impact plant growth. The research study can be interpreted as a first step in the research of natural zeolite as an additive in human hair compost.
In light of the study's conclusion, the agricultural sector stands to benefit from the awareness of the positive impacts of human hair and zeolite compost can have on plant growth. It is recommended that organic compost should be considered as an alternative to the use of chemical fertilizers. In addition, exploring further potential environmental impacts, such as nutrient runoff, leaching, and their effects on water bodies, would allow the development of mitigation strategies for the sustainable utilization of hair compost. Moreover, to develop appropriate application strategies for optimal nutrient uptake by plants, it is suggested that further research is done on the rate and timing of the nutrient release of different soil types and plant species compost in different environmental conditions. Our recommendations resonate with the research findings, thus opening doors for feasible implementation in the field of agriculture and setting a solid foundation for future research endeavors. Through raising awareness and a further exploration, a more sustainable approach to farming can be cultivated, therefore creating a significant process in making a more sustainable future. We would like to extend our heartfelt gratitude to Dr. Brian Limson, our Practical Research Advisor, and Professor Dr. Nonato Santos, our Research Advisor, for their invaluable guidance through the research process. We acknowledge and value the valuable insights and extensive knowledge that they have given. Through their contributions were invaluable in enabling the successful completion of the research study. Lastly, we deeply thank you for being in this Zoom meeting today. We know your time is precious, and we are immensely grateful you were able to carve out some time with us. We're open to answer any questions you may have about our research. Thank you.
A pleasant morning to everyone.
Thank you, Francheska, for that presentation. Again, with your wonderful research, I think this will go a long way in terms of the use of zeolite and hair compost for the Philippines and the farmers. Are there any questions from the audience? Please type your questions in the chat box. So for the for the knowledge of our audience, can you inform the audience what optimum or in what ratio does your compost works well? Francheska?
Sir, the best treatment we had was that 40% zeolite treatment po.
And why did you say that it's the optimum? You said that there is elemental result, that you have what elements present? You have silicon and
Because of the lower pH and the slightly lower electrical conductivity levels po and the steady increase of in-plant growth po, sir.
Thank you. How about I saw Dr. Rodolfo open this mic. Do you have any question, Dr. Rodolfo?
Yung ano, I guess many of us elder
Elder.
teachers and professors will benefit from this if this becomes commercialized. Uh, Question is, when will it become commercialized so we can try it out?
Can
Mga
you
receding hairlines.
yes, can you answer that? Any one of you, Francheska, Samantha, Eishabel, when will this be available? I think who can answer? Katrina.
Sir, excuse me po. We
Yeah.
have no plans to commercialize the product po. We are open for more further research studies for this po.
But you don't need to commercialize, right? Because if you publish the result, like in this case, all they need to do is just follow the procedure, right? Because your intention is really for the use of the farmers, di ba?
Yes po, Doc.
Unless you want to sell. Ang ano dito kasi, yung hair is free, like what Dr. Rodolfo was saying, but the zeolite is not free. Yun lang. Because this has costs. Are there any more questions from the audience? Okay. So, yes, Dr. Rodolfo? Na?
This is a big one, especially from those with receding hairlines like you and me.
Wala na nga, nauubos na nga eh. Anyway, thank you very much, Katrina, Francheska, Samantha, Eishabel, for the presentation and for publishing in the Philippine Journal of Materials and Nanotechnology. So our next presenter, last but not the least, is Dr. Emmanuel Rodolfo. You can go ahead, Dr. Dulfo.